Welcome back to Spring Into Math 8. Today's topic is Pythagorean theorem proofs and its converse. So let's take a dive right in. A little bit of review before we get started. Remember in the last lesson we talked about just the Pythagorean theorem. In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, where you learned that a squared plus b squared equals c squared. Well, here's a little bit of information about the theorem, or the converse of Pythagoras' theorem. In a triangle, if the square on one side is equal to the sum of the squares in the remaining two sides, the angle opposite to the first side is a right triangle. Basically, converse theory is helping us prove that the triangle is what we classify as a right triangle, which is a special type of triangle. Okay, here's an example. A triangle shaped like a piece of cotton fabric is 5 inches long and 6 inches wide. How long is the diagonal of the triangle? Well, that missing side, again, is that hypotenuse part of the triangle we're looking for, opposite of the 90-degree angle. We need to use what we know with the formula a squared plus b squared equals c squared to solve for that missing side. If we insert side A is 6 and side B is 5, we're going to go ahead and square 6 and square 5. Which means 6 times 6 gives you 36, and 5 times 5 gives you 25. And now we're going to go ahead and add those two together, and we get 61. 36 plus 25 makes that 61. So we have 61 equals c squared. We then have to take the square root of both sides of our equation to get rid of the squared over the c. And when we do that, the square root of 61 is 7.81 inches. So the missing diagonal side of that piece of cotton fabric is 7.81 inches long. So how do we identify if a triangle is a right triangle? If the equation a plus b equals c is true for the lengths of a triangle, then the triangle is a right triangle. Sometimes you'll be asked to identify if a triangle is a right triangle. Let's look at an example together. So we have on the side here the green triangle. We have it all worked out for us already, so let's just take a look at it. A squared plus b squared equals c squared, right? So 9 squared plus 40 squared equals 41 squared. We had to actually do the math to make sure this works out and is true. Well, 9 squared is 81, 40 squared is 1600, and 41 squared is 1681. Well, 81 plus 1600 makes 1681 equals 1681. Get a nice red check mark next to that. That green triangle is definitely a right triangle. But we have a triangle in red. And we have some measurements here, 18 feet, 12 feet, and 24 feet. Again, inserting what we know into our Pythagorean theorem formula and solving to see if this is a right triangle. Well, 12 squared plus 18 squared equals 24 squared. Let's do the math and figure it out. 12 squared we all know is 12 times 12, which makes 141. And 18 squared, or 18 times 18, makes 324. And 24 squared makes 576. If I add 144 plus 324, am I going to get 576? Well, I'm actually not in this case. I get 468 equals 576. And those do not equal each other, and therefore we do not have what we call a right triangle. Our green example is green means go, and our red example means red stop. It is not a right triangle. In review, the Pythagorean theorem. In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And the converse also. In a triangle, if the square of one side is equal to the sum of the squares in the remaining two sides, then the angle opposite to the first side is a right angle. Basically, again, the converse just shows us and helps us prove that a triangle is that special kind of triangle we're looking for, the right triangle. That's it for today. Catch you next time.